All right, so like I said, the way you're going to go about finding exam number 2 review, come over here to week 8, click on exam number 2 review. Here's the review document, and then here's the answer key so that you can check your work. Okay. Now, the exam is going to be 25 questions, true, false, multiple choice, a couple of select all that apply questions. They're going to be both some math problems and conceptual problems as well. So having said that, it's obviously the same format as what you had with exam number 1, 80 minutes. You won't need SPSS. You need to use Google Chrome and make sure that you have Proctorio installed on Google Chrome. Other than that, does anybody have any questions about exam number 2? Chapters 4 through 6, but if you don't know some of the stuff from chapters 1 and stuff, you might want to just go review the PowerPoint slides. I wouldn't read those chapters in depth because even though I'm not directly testing you on that stuff, a lot of this material builds on itself. So you still need to know that stuff a little bit. Having said that, any other questions? All right, okay, so let's go ahead and get into this review. And like I said, I will be asking questions, and I want you all to give me the answer. Like I said, you also have the answer key available for you, so it's not really important knowing what the answer is. What's important is knowing why this or that is the answer. So if you don't understand anything, just go ahead and ask, and I will clarify anything that you may need help with. So let's take a look at number 1. So the appropriate measure of dispersion for nominal data is what?
C.
Good. C, index of qualitative variation. Okay. Now, why is this the appropriate measure of dispersion for nominal level data? Well, simply put, it's the only measure of dispersion you can calculate for nominal level data. So having said that, let's just say that you have nominal level data. Kind of like the measure of central tendency, there's only one that you can calculate, and that's the IQV, or the index of qualitative variation. So that's one you're going to want to calculate. Now, if you have ordinal level data, you can calculate IQV, you can calculate the interquartile range or the IQR, and then you can also calculate range. However, which one's the best? So you can calculate this, IQV, IQR, and then range. So the best one if you have ordinal level data is either IQR or range. You would use IQR is if you have extreme outliers in the distribution. Now, if you have interval ratio level data, you can calculate all of them. So you calculate IQV, IQR, range, variance, and standard deviation. But the best one, if you have interval ratio level data, is standard deviation. Because if you remember from chapter 5 and chapter 6 lecture, if you have a normal distribution, if you have the mean and you have the standard deviation, you can learn a lot about a distribution based on just those two pieces of information, the mean and the standard deviation. So the standard deviation is actually the best if you have interval ratio level data. Okay, let's take a look at number 2. If the cases in a distribution are evenly split among the 4 values or the 4 categories of a variable, so that there are the same number of cases in each value, the value of the IQV or index of qualitative variation will be what?
One.
1, good. So as an example, let's just say that we have, I don't know, political affiliation, the Democrats, Republicans, Independents, let's say Marxists. And then we have 5 Democrats, 5 Republicans, 5 Independents, and 5 Marxists. So as we can see, the cases in the distribution are split evenly amongst the 4 categories. Well, then we have maximum variation and maximum diversity, and our IQV is equal to 1. But if we had a situation where we had, let's just say 20 Democrats and no Republicans, no Independents, and no Marxists, well, then we have a situation where there's no variation, there's no diversity at all, and then our IQV would be what in this example?
0.
0. Good. All right. Anybody have any question about that? Okay, good. So we got that. So number 3, the value of the IQV will be equal to 0 if what?
A.
A, if all the cases are in the same category. So good. As an example that we just used, if everybody's a Democrat, there's no diversity, so the IQV is going to be equal to 0 in that situation. Anybody have any question about that? Good. 4, a survey was carried out that compared supporters of the Republican and Democratic parties on opinions about allowing homosexuals to marry to compare the degree of consensus among Republicans with the degree of consensus among Democrats. The appropriate statistic to use would be what? Understand that we're looking at nominal level data, so what measure of dispersion is appropriate for nominal level data?
B.
B, good, IQV. So again, it's important to understand that not just how to calculate this stuff, but also, okay, well, how is this measure of dispersion related to this level of measurement? Good. Okay, so the extreme scores in a distribution have the largest impact on what?
Range.
Good, so the answer is range. So obviously, if you think about what is the range, it's the difference between the highest score in the distribution and the lowest. So I'm going to draw what we refer to as a box plot. So we have the highest, we have the lowest. If you're looking at the IQR, it looks at Q3 minus Q1, and then we have the median here. So with a box plot, you can clearly see range between the highest and the lowest. Now the IQR looks at the middle 50% of the distribution. So as you can see that the IQR is not influenced by those extreme scores. So the range is, but the IQR isn't. And the standard deviation is also not influenced by these extreme outliers. So like I said, if you have extreme outliers, the range is not a good representation of the distribution. You prefer to use IQR. Which of the following is the most reliable measure of dispersion for interval ratio level data?
C.
Good, C. Yeah, we kind of just did talk about that. So does anybody need any clarification on that? Okay. Number 7, a professor found that all of the students in her class were registered for 15 semester hours of classes. This would mean that what?
Would it be D?
D, all of the above. Because think about the range. The range is the difference between the highest and the lowest score. Well, the highest score is 15, the lowest score is 15, right? 15 minus 15 gives you 0. Interquartile range, so well, both Q3 and Q1 are going to be 15, so that's also going to be 0. Standard deviation is going to be 0 as well. So the answer is yes, D, all of the above would be equal to 0. Good. Okay, now let's go ahead and take a look at this data. And so this data is asking us to calculate the variance and the standard deviation. Okay, so let's just take a look at the data right now. And I want you to tell me, what would I need to do in order to calculate variance? So what's the first step when I calculate the variance? Because I need to calculate the variance before I calculate the standard deviation. So what's the first step in calculating the variance?
Do the mean.
Find the mean. Now there are 10 cities up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why don't you all go ahead and calculate the mean for me here? And we will walk through the variance and standard deviation together. Does anybody have the mean or what they think is the mean yet?
I got 17.42.
Good, so the mean is 17.42. Now, what's the next step after we calculate the mean? What do we do with that mean?
You subtract each number from each city, minus the mean. So
Good. Yeah, so you'd do that and you'd find the deviation. And what do we do with that deviation?
You square it.
We square it. Good. And then after we do that for every single score in the distribution, we then sum it up and then divide by what?
N.
No, n minus
10 is minus 1, 9.
n
Yeah.
minus 1. Good. Okay, so let's go ahead and do it together. So we know that we have the mean is 17.42. So I don't have a calculator in front of me, so I need you all to feed me these numbers. So what we're going to do for the first one is 12.9. So we're going to take 12.9 minus the mean of 17.42. When I do this subtraction, what do I get here?
4.52.
4.52. So this is my deviation, the deviation from the mean. And then what do I do with it? Well, we already talked about it. We square it up, right? And then when we square this deviation up, what do we get?
20.43.
20.43. Okay. Now we need to do that for all of them. So let's go ahead and keep going. The next city is 12.6 minus 17.42 gives me what?
Negative 4.82.
So get both of these numbers are negative. 4.82. Square it up and we get what?
23.23.
Next city, 23 minus 17.42 gives me what?
Oh, I think that's there. What did I do here?
0.58.
What's it again? Anika?
5.58.
5.58. Then when we square this up, we get what?
It's 31.13. If we're rounding up, I guess 0.14.
Okay, so 15.6 minus 17.42 gives me what?
Negative 1.82.
We square it up and we get what?
3.31.
14.1 minus 17.42 gives me what?
Negative 2.32.
Square it up and we get what?
5.38.
15.3 minus 17.42 gives me what?
Negative 2.12. And square it up is 4.49.
21.5 minus 17.42 gives me what?
Is 4.08.
Square it up and we get what?
16.65 if you round up.
22.4 minus 17.42 gives me what?
4.98.
Square it up, we get
24.80.
17.7 minus 17.42 gives me
0.28.
square it up and we get
0.08.
and then 19.1 minus 17.42 gives me
1.68.
squared up gives me
2.82.
okay, so we've got all of our squared deviations now. Now what do we do at this point is we sum it all up. Now when you add all of these together, it's going to add up to 137.976. I'm about to erase this. Is everybody like on the same page?
Is it cumulative where you go this and then?
Yeah, so you just add all this together. And then when you add it all together, you're going to get 137.976. So you get 137.976. Divide that by n minus 1. Now we know that there's 10 cities, so 10 minus 1 gives us 9. Now when we do this division, what do we have here?
I get 15.33.
So the answer is 15.33, and then this is the what?
The variance?
Variance, good. Now, if I want this standard deviation, what do I need to do to this variance?
Square root.
Take the square root, and when I take the square root, I get what?
Oh, here it is. Well, function. Oh, that's not right. Okay.
3.92.
Right, so we'll go with 3.92. The answer key says 3.915, but yeah, it's pretty much the same answer. Anybody have any question about that? Okay, good. All right, so calculate the variance standard deviation. We've got both of those. So which of the following values cannot be determined from a box plot? Remember, I just drew a box plot up here. What did I not have up there?
The mean.
Correct, I did not have the mean. I had the median, the exact middle. I had the highest score, the lowest score, Q3 and Q1. So I had the range, the IQR, the median. I didn't have the mean. Good. Okay, so now this is a little bit of a complex question, so I'm just going to kind of answer it for you, unless anybody wants to answer it. Okay, good. So this is the equation for the standard error of the mean. Okay, so this is the standard error of the mean. This is the population standard deviation. I know what you're thinking, they look exactly alike, right? Now the difference between this and this is that there's a line over this y, there's not a line over this y. Now the population standard deviation that we see here is the amount of variation that you see in the population. So when you're calculating the standard error of the mean, the way you go about calculating it is by taking the amount of variation in the population and then dividing it by the square root of n, and then n is the sample size. Okay, so basically what this is telling you is the standard error of the mean is equal to the population standard deviation divided by the square root of n. The standard error of the mean, if you remember from the lecture, is essentially the standard deviation of the sampling distribution. So it tells you how much variation and dispersion you can expect to see in the score in the samples inside of the sampling distribution. Okay, so let's take a look at number 11. So if a hypothesis predicts that self-esteem will decrease as length of unemployment increases, length of unemployment is the independent variable. True or false?
False.
No.
We're deciding. True. Yeah.
Yeah, so if we're saying that, the longer you're unemployed, the lower your self-esteem goes. I know it was written backwards, but it's logical that, your self-esteem technically won't really affect your employment, but if you're unemployed, that could certainly affect your self-esteem, okay? So the answer is true. Length of unemployment is the independent variable. Okay. 2. If a z-score is negative, the original score was below the mean. True or false?
True.
True. Good. Does anybody need clarification on this? Are we all on the same page? Okay, so I saw somebody shake their head. So I don't know if they're shaking their head at this, but they do it anyways. So if you remember normal distribution, this is the mean. If the score is below the mean, it's a negative z-score. If it's above the mean, it's a positive z-score. That's essentially what you need to know for that. Okay, number 13. In a normal distribution, the mean, median, and mode are all equal. True or false?
True.
True.
Good. Now let's just say that you calculate the mean, median, and mode, and you find out that the mean is substantially higher than the median. What type of distribution do you have in that situation? You might see something like that on the exam. The mean is substantially higher than the median.
Is it a skewed distribution?
Good. But it's not just a skewed distribution. Understand what the mean, when the mean is higher than the median, it's a positively skewed distribution. And when the mean is lower than the median, it's a negatively skewed distribution. And of course, when we're talking about, positive and negatively skewed distributions, what causes it? For a positively skewed distribution, it's an extreme outlier or a few extreme outliers on the high side, pulling the mean higher than it should be. And of course, the exact opposite with a negatively skewed distribution, you have a few outliers on the low side, pulling the mean lower than it should be. Okay, good. So 14, a z-score of negative 0.62 is closer to the mean than a z-score of 1.6. True or false?
True.
True. Why is it true? Does anybody need clarification on this? Or can anybody explain this to me?
There's no such thing as like a negative z-score, so it would like turn out to positive 0.62, and so 0.62 would be closer to the mean.
Okay, you're right in one sense. There is no negative z-scores when we're looking in the table. That's true. Because in the standard normal table, you only see one side of the distribution because they hope that you understand that the distribution is symmetrical, so they don't need to show the numbers on the negative side because of the fact that they're the exact same numbers. Okay, that's good. And also, if we're thinking about it in absolute values, okay, one z-score is equal to one standard deviation. Yeah. So if we have 0.62, that's not even one z-score. Now 1.6 is higher than one z-score, which means it's further away from the mean, so it's more than one standard deviation away from the mean. So if we're thinking about it, kind of like the way we drew that graph. So let's just say that we have, here is a z-score of -1, and here's the z-score of +1, okay? Now they're equal distance apart or further away from the mean, but z-score of -0.62 hasn't even got to that -1. So z-score of -0.62, I'm gonna put it over here, has not even gotten to one z-score or one standard deviation away. But a z-score of 1.6 is past this one. So z-score of 1.6 is further away from the mean than a z-score of -6.62. Anybody have any questions about that? Okay, good. So 15, some normal distributions are extremely skewed.
False.
False. A skewed distribution is skewed or extremely skewed. A normal distribution is bell-shaped, symmetrical, unimodal. Good. Good. 16, almost all variables are normally distributed.
False.
Good, false. Now, the first reason why is because in order to have a normal distribution, you need interval ratio level data. And of course, all variables are not interval ratio or are not measured at the interval ratio level. That's the first thing. And the second thing we already talked about, there's positive and negatively skewed distribution. Some real world data is normally distributed, and we can learn a lot about that real world data based on what we know about this theoretical normal distribution. But it is not the case that all or almost all variables are normally distributed. Good. Okay, 17. Sampling that relies on random selection is more likely to result in a representative sample than sampling based on purposeful methods of selection. Now, there's a lot of like big words, a lot of textbook jargon. Let me help clarify this. Okay. So sampling that relies on random selection. So let's just say simple random sample. Let's just say that I took your names and I threw it in a hat. And then I drew out 5 names from the hat for a sample. Well, that's an example of a simple random sample. So that is a random sample. Now, if we're thinking about a purposeful method of selection, let's just say we're talking about snowball sampling. When we talked last week about snowball sampling, I was talking about how maybe I want to do a study on drug dealers, but there's no phone list of drug dealers, so I might have to meet one drug dealer, study him or her. He or she introduced me to other drug dealers, and then my sample gets larger based upon interactions that I'm having with various people. So I'm meeting one person through meeting another person and so on and so forth. So my sample gets bigger, like a snowball gets bigger. So with a simple random sample where everybody has an equal chance of being chosen for the sample, you're more likely to have a representative sample because there's no selection bias. However, with these purposeful methods of selection, like a snowball sample, you're more likely to have a biased sample. Okay? And when we use the term representative sample, what we mean by that is we are saying that our sample looks like our population. So thinking about the COD student body, about 74% Latino, about 15% white, I think like 2.5% black, 3.5% Asian, like a 0.5, like a pointed 0.5% about Native American. So knowing that, if I were to pull a sample of COD students and then 30% is Native American, 30% is black, 30% is Asian, well, my sample doesn't look like the population that I'm concerned about. So I wouldn't, in that situation, have a representative sample. So that's what we mean by representative sample. We want our sample to look like the population that we're concerned about. Okay, 18. Simple random samples will guarantee that adequate numbers of cases from all subgroups in the population will be included in the sample. True or false?
True.
False. Now, this is kind of what I was talking about a little bit earlier, how if we have like a COD student body where we only have like a 0.5% Native American population, so we have some groups that are severely underrepresented at our school. Black population about 2.5%, Asian population about 3%, maybe 3.5%. So if I have a situation where I have these subgroups with extremely small numbers, then I pull a simple random sample, well, my sample is going to look like my population. If in the entire population, we already have a severe underrepresentation of certain groups, well, that sample is going to be even worse. So if I were to pull a sample of 100 students and it's a simple random sample, I might get no Native Americans. I might only get like 1 or 2 African American students. I might only get like 2, 3 Asian students. So no, a simple random sample will not guarantee that adequate numbers of cases from all subgroups in the population will be included in the sample. If you want to make sure that that's the case, what you're going to want to do is do what we refer to as a stratified random sample, where we take the population, we break them up into subgroups. In this example, we're using the example of race, pull Asians, pull a simple random sample out of them, pull Native Americans, we pull a simple random sample out of them, African Americans, we pull a simple random sample out of that group, and then we would know that we have an adequate number from each one of these subgroups. Okay. Anybody have any questions about that? Sampling? Okay, 19. Probability samples will not be affected by sampling error. True or false?
False.
False. Why is it false? Okay, so the reason why it's false is because the vast majority of samples that you're going to pull, sample statistics, are going to differ from the population parameter, at least to some degree. Now, some of them are right on line, but most of them are different. So, yeah, it's just a case that most statistics tend to fluctuate around population parameters. Some a little bit higher, some a little bit lower, some way higher, some way lower, but it's rare to get a sample statistic that perfectly matches the population parameter. So probability samples will also be affected by some type of sampling error. Okay, so in 1995, the math SAT had a mean of 482, standard deviation of 127. Assuming the scores were normally distributed, so we have a normal distribution, the percentage of test takers with SAT scores between 355 and 482 was approximately what? Okay, so can anybody explain to me how I'm going to go about approaching this? What am I going to do first? Just say I'm stuck here. I'm looking at this. I don't understand. Confused. What should be my first step here? We know we're dealing with a normal distribution.
Do you find the z-score first?
Yeah, but like me personally, I would do something different. Something I've been saying in lecture to help us conceptualize what we're going to do here.
Oh, is it when you draw out the...
Good. So what I would do, I would start off by drawing this out. I would draw the normal distribution. And then I'm going to put down the mean. I know the mean is 482. And I know that this raw score is 355. Now, it also tells me that I want to know the percentage of test takers that score between 355 and 482. So I'm going to highlight or kind of like shade in this section. And when I shade in 355 to 482, what column am I looking into? The B or the C column here?
The B.
Good, so I'm going to be looking into the B column. Good. Now the next step that I would do is I would calculate a z-score. So my z-score formula is equal to what? What is z equal to?
I know it's y minus the mean over the standard deviation, but I forgot what y stands for exactly.
Raw score 355, mean 482. So raw score minus the mean divided by the standard deviation. Our raw score is 355. Our mean is 482. Our standard deviation, if you remember from that problem, is 127. Everybody get that? Good. So let's go ahead and calculate this z-score. 355 minus 482 should give you negative 127. Now negative 127 divided by 127 should give you z of negative 1. Z is equal to negative 1. Hopefully everybody's still on the same page. And the fact that it's a negative z-score lets me know that I'm below the mean, so that's consistent. Now what I need to do is I need to go into the table and find the z-value of 1 to tell me what I'm going to see in the B column. So I'm going to jump over to the table. And I'm going to look for 1. So now that I see 1, what do I see in the B column for the z-value of 1.0?
0.34.
1, 3. Good. Okay, so I see 0.3413, which if I'm going to convert that to a percentage, because it says the percentage of test takers that score between 355 and 482, I need to multiply this by 100. Now, when I multiply it by 100, I should get 34.13%, which if I round down is essentially 34%. Now, does anybody have any questions about that? None? Good. Okay, so which of the following best explains why sampling error occurs in probability samples?
B.
B. We kind of talked about this a little bit earlier as well. I touched on it. Like I said, sample statistics just typically tend to fluctuate around the population parameter. Some are a little bit higher, some are a little bit lower, some are way higher, some are way lower. The vast majority are going to be somewhat close to the population parameter, but so the answer is they just always fluctuate around population parameters in some way. Okay, so the central limit theorem describes the properties of what?
Is it population distribution?
Now, we didn't really talk anything about a population distribution.
So sampling.
Sampling distribution, not the sample distribution, because we didn't talk about a sample distribution either. The answer is the sampling distribution. Good. All right, the standard error of the mean measures what?
Is it A?
Good, the variability of the sampling distribution. So similar to the way that the standard deviation measures the amount of variation in the normal distribution, the standard error of the mean measures the amount of variation that you see in the sampling distribution, or the average deviation of the sample means away from the population mean, or you can think about it as the average sampling error in the sampling distribution. Okay. So the standard error of the mean tells you how much give or take around the population mean you can expect to see for the samples in the sampling distribution. Good. Have any clarification on that? Okay, so 24, the variability of the sampling distribution of the mean is affected by what?
Would it be both A and B?
Good. If you ever see some random question where you see like a both A and B, but then it's not there on every other question, so it's like 99% of the time that's going to be the answer. Having said that, well, what does this mean? Now, the variability of the sampling distribution of the mean is the standard error of the mean. And the standard error of the mean, the equation for the standard error of the mean is the standard error of the mean is equal to the population standard deviation divided by the square root of n. Now, if you're looking at that document, it says A is the sample size. So here, if we even look at the equation, we can see that N is the sample size. Now, B is the variability of the variable, which is measured by the population standard deviation, so the amount of variation in the variable in the population. So the variability of the variable combined with the sample size influences how much variation you can see in the sampling distribution. So it tells us the standard error of the mean. Anybody have any questions about that? So you can kind of see it in the equation. Obviously, if I increase my sample size, my standard error is going to be smaller. If I decrease it, standard error is going to be bigger, so on and so forth. Obviously, the more variation I have in the distribution, the larger my standard error is going to be as well. Yeah, these are all kind of like the same questions over and over again. In fact, we actually kind of did this on question 20. So before we actually do this, I want to just make sure that you all know how to do one more thing. That is, I want to make sure that you all know how to do the IQR, how to calculate the IQR. So we're going to take a look at a problem that I think you all had for the homework. So do you all remember how to calculate the IQR? Or the interquartile range? And I'm pretty sure that you need to do this on the exam. In fact, I am positive. IQR, interquartile range, what is the first step? It's somewhat similar to calculating the median, but different, a little bit different. If you have it, Anega, throw it out.
I was gonna say, is it when you add like the first like one to the next one and then so on?
No.
Would you just subtract the, what is it, the Q1 and Q3?
Yeah, but okay, so good. So we need to find Q1 and Q3, but what do we need to do to find Q1 and Q3?
Don't we have to arrange the numbers from the lowest to the highest?
Good. So the first step is we need to take the numbers, we need to arrange them from lowest to highest. So why don't you all go ahead and tell me, like, put these numbers in order and tell me what number is the lowest and put it in order for me. I think the lowest number is probably 2.4, right? What's the next lowest number you see there?
The lowest is 2.2. No?
Oh, you're right. That's why I kind of needed your help. So 2.2 and 2.4 is the next lowest number, right? I think so. Right. 2.4 and then 2.5, right?
Yeah.
What's after that?
2.6. And 2.9. And 3.2. uh, 3.6 twice. Or no, 3.9.
And 4.5, right? So we have all 10 numbers. So there's 10 numbers up here. We've arranged them from lowest to high. So that's first step, arrange the numbers from lowest to high. Now that we know our n is 10, what's our second step? How do we go about finding Q1? Because IQR is Q3 minus Q1. So we need to find Q3 and Q1 next.
You would multiply the n by 0.25.
Good, so we'll take 10, which we know is the n, and we're gonna multiply it by 0.25. And the reason why we're gonna multiply it by 0.25 is because 0.25 is a proportional equivalent to 25%. 25%, of course, is Q1. If you think about $1, you have 4 quarters, so 25. Hopefully that helps you understand it a little bit, right? So 10 times 0.25 gives me 2.5. Now 2.5 is not Q1. Allow me to repeat. 2.5 is not Q1. What do we do with this 2.5? Similar to the median, we count over to the 2.5th number. So we see here we have 1, 2, here we have 2 and 3, but of course with 2 and 3, when we have this situation, we're looking for 2.5, we're looking for the exact middle between these two numbers. So we have 2.4 is 2, 2.5 is 3. We need to find the exact middle to find Q1. How do we find the exact middle between 2.4 and 2.5? What do I do to 2.4 and 2.5 to find the exact middle?
You add them and divide them by 2, right?
Good. So I add 2.4 plus 2.5 is going to give me 4.9. I divide that by 2, and my Q1 is going to be 2.45. So we have Q1. Now for Q3, you're going to do the exact same thing, except instead of using 0.25, because we're not looking for Q1, we're looking for Q3, which is 3 quarters, which would be 75%, which is like kind of like 75 cents. So we do 10 times 0.75 is going to give you 7.5. Now, 7.5 is not Q3, right? We can count over to the 7.5th number. 1, 2, 3, 4, 5, 6, 7. This is 7, this is 8. They're both 3.6. So because they're both 3.6, I really don't need to add them together and divide by 2, because 3.6 plus 3.6 gives me 3.6. So my Q3 is 3.6. So to find my IQR, I'm going to take Q3 minus Q1. So what is my IQR here? What is my IQR?
$1.15.
1.15. Good. So if I take Q3, which I know is 3.6, minus 2.45, I'm going to be left with an IQR, which is equal to 1.15. Anybody have any questions about that? Okay, so that's how you'd go about getting the IQR. Now, looking at these 3 problems, is there any one of those that you want me to do up here so that I can kind of show you the process? Actually, no, 25 and 26 are pretty much the same thing. Let's do 27. Let's do 27 together. So a business uses a 7-point scale about satisfaction with services it provides to clients. The ratings are normally distributed with a mean of 4.8 and a standard deviation of 0.5. What percentage of clients rate their satisfaction between 4 and 5? So if I saw this, how would I start this? What should I do first?
Want to draw it out, I guess?
Good, so I would draw it out. The mean is 4.8. And I'm looking between 4 and 5. Okay. Now, so in both situations between 4.8 and 5 and 4 and 4.8, I am going to be looking into the B column. Between the mean and the score, between the mean and the score. Now, what I need to do also is calculate a z-score. So we know that a z-score, let's just say I do it for 5. Z is equal to 5, which is the raw score minus the mean of 4.8, divided by the standard deviation, which we know is 0.5. So we do 5 minus 4.8, we're going to get 0.2. We're going to take 0.2, we're going to divide by 0.5, and we're going to get a z, which is equal to 0.4. Everybody still with me? Cool. Now we also need to do this for 4. So if I were to do this for 4, I would do a z, which is 4 minus 4.8 divided by 0.5. So 4 minus 4.8 is going to give you negative 0.8 divided by 0.5. You're going to z, which is equal to negative 1.6. So we're going to look for a z, which is equal to 1.6 in the table as well. So I'm going to bring this table back up, and we're going to look for 0.4 first, 0.40. And when I look for 0.40, I see 0.1554 in the B column, 0.1554 in the B column. And then when I go to 1.6, I see 0.4452. Okay, which tells me that here, if I were to round this up, 15.54, what percentage do I have? I have 16%, because 15.1554 times 100 is going to give me 15.54%. I'm just going to round that to 16%. And then here I have 0.4452. Okay. Now with 0.4452, if I multiply that by 100, and then I round it to a whole number, whole percentage, I would have 45% here. So I would add these two together and I would get about 61%. 61% of so that means that 61% of clients rate their satisfaction between 4 and 5. All right, having said that, that's pretty much all I really had planned out. Does anybody have any other questions about, one, anything that we discussed in the review or the material, or does anybody have any question about anything else while they were studying for the exam coming up?
I appreciate you reviewing like this. This really helped me out. Thank you.
It's what they pay me to do. It's my job. So no problem. Anybody have any questions about anything? Okay, well, I will stop the recording now.